binary trees. So what is the problem? Given two binary trees, and imagine that when you put one of them to cover the other, some nodes of two trees are overlapped while others are not. If you need to merge them into a single binary tree, the merge rule is that if two nodes overlap, then some nodes value up as the new values of the merged node. Otherwise, the not null node will be used as node of new tree. So if we see here, this is our tree 1, this is our tree 2, and how merging is happening. If we put tree 2 on the top of tree 1, then this node 1 and 2, these nodes will overlap. So if you see, suppose this is our resultant tree, so we will have 2 plus 1 3 value, 3 here. Then because of these two nodes 3 and 1, these two will overlap, so we will have 3 plus 1 4 value here. This 5 will not overlap with anything because there is no node here, so here we will have 5. Here we don't have any node, but here we have 4, so it will become 4. We don't have any node at this particular location, so no new node will come at this particular location. This location we have only one node 7, so 7 will come, and this location will have 2 and 3, so 2 plus 3 5 will come. So this is our resultant tree. Okay, so now how we will formulate the solution? It will be obviously a recursive one, but how to think about the solution? So approach that we will use, since we have two trees already, tree 1 and tree 2, we can use either of them to make the resultant tree. Okay, so this tree we don't need to make a new tree, we can just modify the existing one. So let's say I will modify the tree 1. So when I will traverse down both the starting from both the root node. I will add the value in this position only. So this one I will make 3. Then I'll go for the left subtree, root of left subtree. So left subtree is this, left subtree is this, but we will consider root of left subtree first. Since 3 and 1 are overlapping, so I will make this value 4 here. Then I'll go in the left subtree of 4, left subtree of 1. So there is no node here, so I will read this as it is 5. Here we have 4, but here we don't have any node. So since here we don't have any node, we'll create a new node that will be 4. And so now we are done with the left subtree of both this and this. This is completed. So now we can move to the right subtree of root of the tree. So now 2 and 3 are overlapping. So what I will do, I will add them. 2 plus 3 5 here, and then again do the same thing. Left subtree of 5, left subtree of 3, nothing, so skip. right subtree of 5 nothing, but right subtree of 3 is 7, so I will add a new node 7 here, and I will return this tree 1. So actually the tree 1 will be my result, and so this is nothing but a tree 1, modified tree 1 after all the recursive calls. Okay, so now we will go about coding it. So we are doing this in Python 3, and we know the tree structure: value, left and right, three things that are there in the tree. So basically in the any recursion there are two parts: base condition and recursion, right? So I will write recursive part first. And what will be the recursive part? So if so let us consider we have handled if there is any one of them null, we will handle. So in the base condition we will handle if either t1 node is null or t2 node is null, then what needs to be done? So if both are null, then answer will be null. If both t1 and t2 both the nodes are none, then our answer obviously will be null, none. So if you want to write the base condition, so if t1 equal to none and t2 equal to none, then that means both trees are empty. So our answer will always be an empty tree, none. And if we see if only one of the node is none, then other node will be the answer. For example, here since the right of 2 is none and right of 3 is 7, so we will call here none and 7, so obviously we will return the 7 tree. So second condition in the base case will be if t1 equal to none and t2 not none, right? If t1 is equal to none and t2 not equal to none, then we will return t2, and vice versa. So if t1 not equal to none and t2 equal to none, then I will return t1. So this is our base condition. And the recursive part, so if we will come to the recursive part only after completion of this code. So none of these base condition is met, and now we are ready to write the recursion. So that means both t1 and t2 are not none. So what we should do? So I want everything the resultant in the t1, right? So first thing, t1 dot value I will update. So I will add in the t1 value, I will add t2 dot value. This is the first thing that I will do, like 1 and 2 will be added. Then now I need to call the recursive calls, recursion here, and the recursion. So let's make recursive call merge tree. So we will call with t1 dot left. We want to merge t1 dot left with t2 dot left, and whatever we the output means, whatever this function return, this function will return the resultant of t1 dot left and t2 dot left. If this is t1, this is t2, we will get the merged subtree of t1 dot left and t2 dot left. So that will become the left child of t1. So return value of this function will be the left child of t1, and similarly the right child of t1 will be t1 right and t2 right. So we will call the recursive function for t1 right subtree and t2 right subtree, and whatever be the resultant tree, that will be the right subtree of t1, and in the end we will return t1. So result is t1 now, so we will return t1. Let's check whether it works or not. Running code. Okay, so I forget to write this keyword self self. It is perfect. Try to submit it. It's perfect. So this was merging two binary search tree. If we talk about the time complexity of this, so what is the time complexity? If this tree one size is n, or better we say here, if tree one size is n and tree two size is also n, then we are actually traversing both subtrees fully. So time complexity will be big O(n). So that is all about this problem. Signing off.